This video is part of Unit 2. The purpose of the video is to provide a level of background understanding for the two parts of the Magnetic Forces Lab. Investigating invisible forces, exploring how forces work without touch. Lesson objectives. In this lesson, you will learn about the invisible forces that act between objects even when they seem far apart. You'll discover how to conduct experiments and evaluate their design to understand these magical seeming forces. By thinking like young scientists, you're going to explore the mighty forces of gravity and magnetism. Learn how objects exert forces on each other without touching. Learn how to plan and conduct scientific investigations, and learn how to evaluate the design of experiments. Some of our unit vocabulary words are balanced force, unbalanced force, and net force. The definition of balanced force is when forces acting on an object are equal in size but opposite in direction, resulting in no change in the object's motion. Unbalanced force means when forces acting on an object are not equal, and this causes a change in the object's motion. Net force means the overall force acting on an object when all of the individual forces are combined. Magnetic force, electric current, electromagnetic. Magnetic force means the push or pull that a magnet exerts on certain metals like iron, nickel, or cobalt. Electric current means the flow of electric charge through a material, usually in the form of moving electrons. Electromagnetic means the connection between electricity and magnetism. Some more words that you'll need to know as we go through this unit are gravity, a force that pulls objects toward each other. Gravity is why people stay on the ground and do not float out into outer space. Magnetism, a force that can attract or repel objects without touching them. Field, a region or a space where a particular force like gravity or magnetism acts. So if you are in the magnetic field, or if an object is within the magnetic field of something else, and it's magnetic, it will be pulled toward that magnet. If an object's within the gravitational field of another object, it will be pulled toward that object. Investigation, a careful study or experiment that is done to learn more about something. Observation, noticing and recording what happens during an investigation. Evidence, information and facts collected through observations during an investigation. Experimental design, the way an experiment is planned out. This includes the steps and the methods used in that experiment. Variable, something that can change in an experiment, like the distance a magnet is from a paperclip. Control, a part of the experiment that does not change. This makes sure that the test results are fair and repeatable. Inertia. Inertia is a property of matter by which that matter continues in its existing state of rest or motion in a straight line, unless the matter is changed by another force. So another way to say this, inertia means that an object wants to keep doing what it's doing. If it's staying still, it wants to stay still. If it's moving, it wants to stay moving in that straight line until another force changes what it's doing. There are many practical uses of understanding how forces around us work. You could use a magnet to collect nails that fall on the ground without touching them directly. So for the past I don't know, 10 or 12 years, I've helped my friend who works in construction during the summers, and I help him replace roofs on houses and businesses. And so when we're ripping a roof off of a house that needs to be replaced, the first thing we do is we pop the shingles, and when we do that, nails go flying in all directions. When we stop for the day, we have to make sure we get those nails off of the ground because they can be dangerous to pets or people if they step on them. They can damage bicycle tires or lawnmower tires. And so we take a magnet that looks similar to the one in the picture here, except for ours has wheels on it, and we wheel that magnet back and forth across the ground several times. And this helps us because sometimes we can see the nails, but sometimes when they fall underneath the grass, we can't see them. But the magnetic force, the magnetic field exerted from that bar magnet is able to pull the nails out of the grass without touching them. And then the nails get stuck to the magnet, and we can carefully dispose of them so that nobody steps on them, nothing runs over them. I want you to take a minute now to think about what are other ways magnets or gravity could be used in your daily life to make jobs easier. As you are thinking about this and as you're writing your 1 to 2 sentence response, pause the video. When you're done, push play so that you can continue watching. All right, exploring invisible forces. There are forces in nature that act even when objects are not touching. Gravity is one of these forces. Gravity is a force that pulls objects toward each other, like how Earth pulls you down so you don't float into space. And what most people think is that Earth has the gravity, but actually anything that has mass has a gravitational force that it's exerting on the objects around it. And so, yes, the Earth has gravitational force that it's pulling against your body, but in the same way, since your body has mass, your body has gravitational force that's pulling other objects, including the Earth, towards it. Now, the greater the mass, the more noticeable and the stronger that gravitational force is. And so we can easily notice that Earth has a strong gravitational force against smaller objects around it, like the stool that you're sitting on, or your pencil, or even yourself. But all of those objects also have a smaller gravitational pull on objects around them. All right, let's keep going. Another invisible force is magnetism. Think of how magnets can push or pull other magnets without even touching them. These forces are called fields, and they exist between objects exerting forces on each other. If we look in the illustration here, we see a bar magnet with the 2 south poles of the magnets facing each other. And when we do that, the south poles push against each other. And you can see they're not touching, but they're pushing each other away from each other. If I were to spin the 1 bar magnet around so that north is facing south, instead of pushing each other away, they would be pulled towards each other. Let's keep reading. Understanding these invisible forces helps us explain everyday phenomena like why magnets can stick to your fridge or why you don't float away from Earth. Let's try it. Exploring invisible forces. How does gravity affect you every day? This is kind of a tough concept to think about because you take gravity for granted. You don't even stop and think that you're going to stay on the ground when you take a step. So I want you to think about another way to help you understand this might be think about what it would be like if gravity stopped working. If there was no gravity, how would your life change? And so that's going to help you answer this question. Pause the video and write 1 or 2 sentences here to tell how gravity affects you every day. All right, let's try it together. Exploring invisible forces. If a magnet pulls a paperclip from 2 centimeters away, how far is the field acting? So the magnet is not touching the paperclip is 2 centimeters away from touching the magnet. How far is that magnetic field? Take a minute, think about it, enter a number. All right, you should have been able to say that the magnetic field is 2 centimeters. Becoming young scientists. When you conduct a scientific investigation, you start by asking a question. For example, you might ask, how does the distance between a magnet and a paperclip affect how strong the force is? Then you can plan an experiment to find this out. You might move the paperclip closer and further from the magnet and then observe what's happening. Record your observations carefully because they are important evidence. By learning to conduct investigations, you can answer your questions about how things work, and you can find evidence to support your ideas. Let's try it, becoming young scientists. What question might Annika ask if she wants to find out more about magnets? Go ahead and pause the video while you write 1 to 2 sentences telling us what question Annika might ask if she wants to know more about magnets. Let's try it together, becoming young scientists. All right, so think about this question, then choose the best answer, and then we'll continue. So what should Carlos do first in his investigation about gravity? So the first thing he should do when he's conducting an investigation about gravity. A, he should record his observations. B, he should ask a question about gravity. C, he should write down the results. D, he should conduct an experiment. Take a second to think about this. All right, you should have been able to identify that Carlos should ask a question about gravity first before he does anything else in his investigation. Judging experiments like a scientist. Evaluating an experimental design means checking if the experiment is fair and if it actually tests what you want to learn about. You need to see if the steps are clear and if there's anything that might mess up the results. This might mean checking if you're only changing one thing at a time, like moving the magnet closer or further from paperclips to see the effect. If we change too many things at once, we're not really sure what's causing the outcome in the investigation. So you want to make sure you're only changing one thing at a time. By evaluating experiments, you can improve them to get clearer and more accurate answers to your questions. Let's try it, judging experiments like a scientist. Which part of Maya's experiment needs to stay the same to ensure a fair test? Does she need to keep the color of the magnet the same? Does she need to keep the type of paper used the same? Does she need to keep the size of the paperclip the same? Does she only need to conduct this investigation on the same day of the week every time she does the investigation? Take a minute and think about which one needs to stay the same to make sure her test is fair. All right, you should have been able to identify that C, the size of the paperclip, is what needs to stay the same as she's conducting this experiment. Let's try it together, judging experiments like a scientist. What is one thing you should check when you are evaluating an experiment? You're going to need to probably pause this video while you type your answer. Again, just write 1 or 2 sentences to tell what's one thing you should check when you're evaluating an experiment. Think about the lesson. What is one thing you learned or one question you still have about today's lesson? You can write a sentence or you can draw a picture of what you're thinking in answer to this question. If you do draw a picture, make sure you include labels or a caption to help me understand what your ideas are. Pause the video while you make your response, whether you're writing a sentence or you're drawing an illustration with labels or captions. When you're done, push play so that you can continue watching the video. Exit ticket. Exploring invisible forces. Which of the following shows that fields between objects exist? A magnet pulling a nail towards it from a few inches away. A person pushing a door to open it. A book resting on a table. A car rolling to a stop at a red light. Go ahead and think about that for a minute. All right, you should have been able to identify that a magnet pulling a nail towards it from a few inches away is showing a magnetic field existing between these two objects, even though they're not touching. All of the other choices show something is touching, two objects are touching. So the person touches the door as the person pushes it to open it. A book is touching the table as gravity is holding it in place on the table. The car's brakes are touching the car wheel as the car stops at a red light. Exit ticket, becoming young scientists. Why are observations important in an investigation? Write 1 to 2 sentences to tell why observations are important in an investigation. Remember, observations are what you see and record during your investigation. Pause the video while you write your 1 to 2 sentences to tell why observations are important in an investigation. When you're done, you're going to push play to continue watching the video. Exit ticket, judging experiments like a scientist. If Sean keeps the distance between a magnet and a paperclip at 3 inches, what part of the experimental design is this? You may need to pause the video and look back at your notes on the previous pages to understand what they're asking. But once you know what they're asking, write 1 to 2 sentences to answer this question. When you're done, push play to go to the last part of this video. All right, finally, this is the last part of the video, and this is a cool video of a high school teacher showing his high school students how gravitational force works. You're going to push play right there in your notes packet. We're not going to watch it in the video that I've recorded, so you can close this video, but in your notes on the last page, you're going to push the play button right in the middle of that video, and when you're done, you'll be able to submit your notes. Thank you for watching.